about astronomy today. Okay? So we're going to switch gears and look at design in our universe. Okay? Because the psalmist says that the heavens declare the glory of God. And so when we look out there, we should see some really cool design. So we've actually gone from biology, which we use a microscope for, and now we're going to exchange our microscope for a telescope. Okay? Now, a few years ago, I really wanted a telescope really badly. Now, they're really expensive, so I started saving up for one. And then I actually never ended up buying one because I just couldn't justify spending the couple $1,000s that it would cost to get the one I wanted. But you know what? You can look online and see these really cool pictures that people have taken using these telescopes. So I thought, you know what? That's probably good enough. So we're going to look at astronomy. Now, what is astronomy? What does astronomy mean? Let's go this guy in the back. Oh, you put your hand up and then you put it back down.
Astronomy means is to...
You're looking at the definition, aren't you?
To say like objects, like stars, planets, roads, and comets, galaxies.
Yeah. So it's all those things. It's a study of, now this word is a kind of a science word, celestial. It just means sky. So it's a study of sky objects like stars and planets and moons and galaxies. Those kinds of things. So here's a galaxy, there's the sun, there's the moon. One of the reasons I love astronomy is because it's one of the oldest sciences in the world. Biology really just took off a few hundred years ago, but astronomy has been studied for thousands of years. In fact, we find these formations. This is Stonehenge. And we really didn't know how the people did this at that time. These ancient people created this thing. These stones are actually quite heavy, and they're in the upright position. We thought, what is this thing? It turns out this is probably an ancient calendar that they were using, okay? Using them to keep time. The pyramids, the way they're structured, and again, did you know that a lot of people, even today, think that aliens did this? Because they don't think that people, primitive people, were able to think to do something like this, had the smarts to build something like this. Now we know ancient people, going all the way back to Adam, would have been brilliant. Okay, think about that. Adam and Eve were created by the hand of God, so they would have been smart people. And so, from a Christian perspective, we can make sense of things like the pyramids. But they actually have, they actually use astronomy as well, and some of them were used as observatories. Now, even today, modern scientists study astronomy. There's actually a group called NASA. Have you guys heard of NASA? So NASA, their job is to study the heavens. And they build rockets, they build space shuttles, they build satellites, and they study the heavens. A few missions that have happened recently are the missions to Mars. This is actually a robot, an unmanned robot that was sent to Mars. It's called Spirit, and it has like a twin that was called Opportunity. So Spirit and Opportunity are just cruising along the surface of Mars. In fact, there's camera on Spirit. He went for a ride and then turned around, and this is a picture of his tracks on the moon, or on Mars. And so Mars is really cool. Now Mars is far away. Mars is actually 55 million kilometers away. It took Spirit and Opportunity about 300 days to get to Mars. It's a long travel. That's one way. So we haven't gone there yet. In fact, we don't know how to get there safely, because once you get out of our atmosphere, it gets really dangerous out there. And I'm going to show you why. You'd have to be able to survive for 300 days one way, then be able to get back. That's almost a year. Now think about that. 2 years in a space shuttle to go there and back. Something that scientists and astronauts are working on. We've been to the moon. We've actually put our feet on the moon, and that was a big deal. I know some of you guys think, oh, that's just, everyday things now. We go to the moon all the time. Well, we haven't been in a while, and when we first went to the moon, it was a huge deal in 1969. Okay? Does anyone know who the first people to step on the moon, what their names were?
Neil Armstrong.
Neil Armstrong. Does anyone know the other guy? Because he was the second guy, and he doesn't get much.
Astronauts?
He was an astronaut for sure. Does anyone know what his name is? It was Buzz Aldrin, okay? Nobody knows who Buzz is, but he was the second guy. So we've been to the moon. Now I'm going to tell you about one of my favorite space stories, okay? it has to do with Apollo 13. Now, Apollo 13 was a mission to the moon. Now, we've already been twice to the moon since then. We went Apollo 11. Now, that was Neil Armstrong and Buzz Aldrin. They actually stepped foot on the moon. Then there was Apollo 12, and Apollo 13 was the third mission to the moon. Now, this took place on April 11, 1970. They launched from the Kennedy Space Center, and everything seemed to be going fine. Unfortunately, Apollo 13 would actually never make it to the moon. Now, they were in a magnificently designed spacecraft, okay? But about 55 hours and 54 minutes into their voyage, something went terribly wrong. There was a huge explosion, okay? And then there was these famous words. Maybe you've heard these words.
I know.
What were the words?
Houston, we have a problem.
Yeah, Jack Swigert, one of the astronauts on Apollo 13 mission, says, Houston, we have a problem. And they had a huge problem because one of the oxygen tanks, oxygen tank number 2, exploded on their space shuttle. These guys were 200,000 miles away from Earth and traveling in the wrong direction. They weren't coming towards Earth, they were going away from Earth. Now, 2 of the 3 fuel cells that power the space shuttle, the spaceship, were down. They were dead. And the last one was rapidly depleting. This was a serious problem. They hadn't trained for this. Even the drills where they would simulate things going wrong, they never, in their wildest dreams, imagined that this would happen. Okay? And so oxygen was depleting from the space shuttle. They needed all of their carbon filter, the carbon dioxide filter was damaged. Water supply was low. In fact, for the rest of the mission, the astronauts could only take 175 milliliters of water per day to conserve it. Okay? Imagine that, 175. Next time you grab a bottle of water, what's a bottle of water hold? 500? Just 175 milliliters of water a day. The heat in the cabin was dissipating. They couldn't even heat up their space shuttle, so they were freezing cold. Now, the reason I'm telling you all this is because the Apollo spacecraft was magnificently designed for traveling in a very hostile environment, space. Our Earth is also magnificently designed, which we'll see, and so is the universe. But you know what? If something goes wrong, then we're in big trouble, okay? So they have to be designed for our survival. Now, these things are designed. The design, we say, is balanced on a razor's edge. It's kind of like if you were walking a tightrope. Have you guys ever, did you watch the Niagara Falls tightrope? That was pretty cool, right? Now, he had a harness on. Now, some people have imagined running a wire across 2 buildings, and there's no safety harness, and just walking across. If you were to go on either side, what happens? You would fall. You would fall, and you would die. This is like the design of a space shuttle and Earth. They have to be finely tuned, balancing on like a tightrope, and if you were to go on either side, and if the design isn't just perfect, then it won't sustain life. It won't support life. Literally, if you fell, you would die. And so, if something goes wrong with the spacecraft, then you'd have big problems. Now, what has to be just right? Oxygen level has to be just right. The CO2 level has to be just right. The temperature, the pressure, the water, all of those things have to be just right. And it's the same with Earth. It has to be just right for Earth as well. And if something does go wrong, if one of these values is off, then as we saw with Apollo 13, their lives could be in jeopardy. Now, they actually arrived home safe on April 17th, 6 days later. They were able to bring them back alive, which was amazing. They actually termed Apollo 13 a successful failure because it went from going to the moon to just bringing these 3 astronauts home alive. And if one of these values is off with Earth, then it would be inhospitable for life as well. Let me show you some of these, okay? These are going to be cool. The atmosphere, the Earth's atmosphere contains oxygen. It's actually at 21%, okay? Our atmosphere is 21% oxygen. If that were to change, if it were a few percent more, then fires would spontaneously erupt on Earth. Yeah, if there was too much oxygen. And this would actually make life on Earth very difficult. If it was a few percent less, you would suffocate, and so would most animals. Okay? So 21 seems to be this number, this magic, just right condition for life. Have you guys heard of Goldilocks and the Three Bears? Yeah. Okay, in Goldilocks and the Three Bears, we hear when she gets the porridge, one is what? Too what? Too hot. Too hot, and one's too cold. Too cold, and one's just right. Well, there's something in astronomy called the Goldilocks principle, and it's like this. Earth is just the right distance from our star, which is called the sun. It turns out if you were a little bit closer, that's where Venus is located, if you were a little bit closer to the sun, it's too hot. In fact, Venus is 700 degrees Fahrenheit. 700 degrees. You couldn't live there. It turns out a little bit further from our planet, further from the sun, you have Mars. Now Mars is about 0 degrees Celsius in the summertime. Okay? That's at the equator. So you wouldn't want to go there on a, Christmas vacation somewhere tropical. No, Mars is not a good place to go. In fact, most of it is, there's a lot of solid ice on it. So this zone in here seems to be the life zone, the life-permitting zone. Now it turns out the temperature is really important for water as well. You cannot live on the planet without liquid water. Now on our planet, well, on Venus, there's no liquid water. In fact, it's all water vapor. Okay? That's all they got is water vapor. On Mars, all they have is ice. Now, scientists are really excited. They found ice on Mars, and usually, their hypothesis is, if you can find liquid water, then maybe you'll find life. And that's why they're really excited about this water, solid water on Mars. Okay? Now it turns out on Earth, we have all three stages of water. We have solid, liquid, and gas. Okay? And that's what makes life on Earth habitable. We actually have 70% of our planet is covered in water. 70%. Very cool. Some other things that have to be just right. The size of our planet needs to be just right as well. If our planet was too big, what would happen? It turns out that as you get a bigger planet, you get more gravity, and it would pull in more atmosphere, and that would cause a runaway greenhouse effect. And our planet would end up looking like Venus. Venus has a greenhouse effect problem where, have you guys ever been in a greenhouse? Yeah. It's really warm in a greenhouse. That's why they put all the plants. When the sun rays come in, they get trapped and they can't escape. And that's why it gets really hot. Our atmosphere will do the same thing. And so our planet would be like Venus, too hot. If it was too small, it couldn't hold an atmosphere. The gravity would be too little, and it would look like the moon. The moon has no atmosphere. So if they go to the moon, they got to wear their suits, and that pumps oxygen to them so they can breathe. These astronauts. Now, if you take your mask off, what will happen?
They'll die.
Well, you wouldn't be able to breathe. You'd suffocate because there's no oxygen on the moon. Okay? But our planet is just the right size for just the right atmosphere. Okay? It's very cool. In fact, the size also affects gravity. Have you guys seen them jump on the moon before? No. Well, the astronauts, when they jump on the moon, they're able to jump really high. That's because there's less gravity pulling them towards the Earth. When I jump, gravity pulls me back towards the Earth. Now, it turns out if Earth was really, really big, you wouldn't be able to jump at all. In fact, gravity would be so heavy, you wouldn't even be able to stand up. A planet like Jupiter, which we'll see in a second, would have such a huge gravitational pull that life would be impossible. And if it was too small, if the planet was too small, you may jump and never reach the ground again. Just take off. Okay? Okay, that our Earth is actually tilted when it spins. Now, this is really important. If it wasn't tilted, this is what would happen. The sun rays coming towards the equator would be so hot, it would be unbearable. And it would be so cold at the poles that it would be unbearable as well. In fact, our Earth is tilted at 23.5 degrees. What does that mean? It means that the coldest it gets on Earth is only about, well, it's still pretty cold, minus 90 degrees Celsius. So this is where the penguins like to hang out, okay? I prefer not to go there. At our equator, it can get up to like 60 degrees Celsius, believe it or not. But you know what? That's actually pretty good, considering if it wasn't tilted like this, it would be a lot hotter and a lot colder at those extremes. Okay? So the tilt of the Earth is even designed. We need this tilt for our survival. Here, this one's really cool. Okay? Now, this guy right here is Jupiter. He is huge. You could fit 1,300 Earths inside the volume of Jupiter. Okay? Now, here's us. So we have Mercury, Venus, Earth. Okay? Now, here's a problem that we would normally face if it wasn't for Jupiter. Let's say we have a comet. Okay? Or sorry, an asteroid. If this asteroid were to come towards Earth, because there's lots of asteroids in our solar system, if an asteroid were coming straight for us, if it were to hit our planet, life on this planet would probably all die. Okay? But luckily, check this out. The asteroid starts coming towards Earth, but Jupiter acts as a cosmic vacuum cleaner. It actually sucks up all the space junk. Okay? So we should thank God. We should actually thank God that there is a planet like Jupiter that's doing that for us, that's protecting us. It's like a bodyguard, okay? And it attracts all of these asteroids. Now, some scientists have said, well, that's just how solar systems form naturally. When we actually look out at the universe, we see that most of the gas giants are what form close to the sun, and the terrestrial planets, like Earth, form away from the sun. Ours is just the opposite. It's almost like it was planned to be this way, okay? That there was design in mind. So our place in the solar system is designed. Our place in our galaxy is actually designed as well. Now, you may be thinking, hey, shouldn't we be at the center of our galaxy? No. We don't want to be at the center of our galaxy. The radiation there would kill you, okay? In fact, even if you lived in one of the spiral arms, this is called a spiral galaxy. Does anyone know what our galaxy is called? This guy. The Milky Way galaxy. You got it. So this is called the Milky Way galaxy. We actually live between the spiral arms. That's actually the safest place to live because the radiation is the least. Every star that you see in here, and there's 100 billion stars, is giving off radiation. And so you want to be as far away from the stars as possible, but not too far. Remember, you want to be close enough so that your planet stays warm. Okay? It turns out that the galaxy is 100,000 light years across. Now what that means is, light year is not a time, it's a distance. Now when you're measuring your height, we would say that you're this many feet tall. Like I'm 6'4". I'm over 6 feet tall. But when you're measuring the distance across a galaxy, using feet and meters and kilometers isn't enough. We need something bigger. So we use a light year. A light year is 10 trillion kilometers. 10 trillion kilometers is 1 light year. This is 100,000 light years. That's how big our galaxy is. Okay? Now, something really interesting here if you were to count all of the stars in our galaxy, and it took you 1 second to count each one, so you went 1, 2, 3, to count all of them would take 2,500 years.
What?
Okay? So you would have had to start counting, to count all the stars in our galaxy before Jesus came on the scene. 2,500 years ago, you would have started to be finishing right now. So that's our galaxy. Now, it's no wonder David said, the heavens declare the glory of God. Now, I want to show you something cool. This is a picture taken from the Hubble Space Telescope. This is called the Hubble Deep Field. Now, there's actually in September of this year, there's a new photograph that just came out. I was going to try and get the video, and it was too long, and so I didn't bother. But there's a new photograph called the Hubble Extreme Deep Field. And it actually has even more pictures. What they did was they took a spot in the night sky from a satellite orbiting the Earth, and it was just pitch black. And it was the size of a grain of sand held at arm's length. And they said, let's focus our camera on this spot, this black spot, for 10 days. And they did that. For 10 days, they focused on this one spot. Now, it could have happened that there was nothing there, and it would have come back black. Just empty space. But what came back was what you're seeing right here. Each one of the specks of light on here is an entire galaxy.
What?
So I showed you the Milky Way galaxy, 100 billion stars. Every speck you see on here is its own galaxy. Are you starting to see that the Psalmist was trying to tell us something? The heavens declare the glory of God. A few centuries later, the prophet Isaiah actually said this. It was actually God speaking. He says, "To whom will you compare me? To whom is my equal, says the Holy One." This is God speaking. He says, lift your eyes and look to the heavens. Who created all these? And then it says, he brings out their starry hosts one by one and calls them each by their name. So he actually calls every single one of the stars in all of the universe by name. You think he knows you? Absolutely. We'll come to that in a second. So here's this photograph that was taken. Every speck of light you see here is a galaxy, not a star. It's a galaxy.
There's another Milky Way.
There's lots of spiral galaxies. There's different shapes to the galaxies. Every speck. It's awesome. All right, you guys think that's cool? I think that's cool. So just so you are aware, the universe is huge. Now we call it the known universe because it's only the part we know about. There may be parts beyond what we've even seen. Well, for sure there is. Let me give you a sense of how far apart or how big the galaxies are. So every star in our universe approximately is 30 trillion miles apart. Okay? Every 2 stars. If you got into a space shuttle and you traveled at 5 miles a second, that's flying pretty quick. 5 miles a second? That's close to 20,000 miles per hour. If you got in your spaceship and you started going, it would take you over 200,000 years to go from one star to another star. And that's just 2 stars. Remember, there's 100 billion stars in our galaxy and over 100 billion galaxies. So this universe is humongous. Here's some pictures. These are all different galaxies we've taken pictures of. Okay? They call this guy right here the Sombrero Galaxy. Kind of looks like and you're actually seeing an edge on. Very, very cool. These 2 galaxies are actually on a collision course with each other, which is kind of neat. They're just going to kind of explode there. So here are some others. Really cool, right? There's a whole group of galaxies. excited. This gets me excited too. I want to tell you about this galaxy here. This galaxy is actually called a globular cluster. Kind of a weird name. It's so thick with stars that that there's probably a trillion stars in here. I know he said most galaxies have 100 billion stars. This guy probably has 1 trillion. Now, if you were to live in this galaxy, like a planet we're in here, you would not be able to see anything in the night sky. It turns out that our galaxies and our position in our galaxy is perfect for observing other galaxies. If you lived in this galaxy, you wouldn't observe anything. It would be bright all the time. Okay? It would be bright all the time. You couldn't actually live there because, again, the radiation would be unbearable. One second. I'm just going to finish up here and then we'll take questions. So listen, David tells us, and you guys should memorize this verse, in Psalm 103, verse 11, it says, "For as high as the heavens are above the earth, so great is the love of those who revere him," or honor him, okay, or treasure him. So when you think about it, as high as the heavens are above the earth, how high are the heavens above the earth? Well, don't get this out of your mind, because what you should be thinking of is this, okay? That picture we looked at with all the galaxies. The universe is huge. And so this whole time, we've been talking about astronomy, but in reality, we've been talking about God's love. Because as high as the heavens are above the earth, so great is the love that he has for you, okay? So when we say, how much does God love you? Don't think of like a teddy bear saying, I love you this much. Let's get rid of the teddy bear. He loves you this much, okay? And in fact, he loves you more. He's comparing himself to the universe. But really, he loved you so much that he actually sent his son to die for you. So not only did he design this incredible universe for you to live in and to observe, but he actually loved you so much that he came to this world and sent his son to die on a cross for everyone who believes in him. Okay, that's John 3:16. So this world, although it is designed, this world has actually been corrupted, hasn't it? This world, what happened in the Garden of Eden? What happened in the Garden of Eden? Do you remember? Adam and Eve? That's right. So in the Garden of Eden, remember that Adam and Eve disobeyed, and so they were kicked out of the perfect garden. There was a curse put on the earth. But all of that is going to be restored. So the universe, the earth, the heavens are all going to be restored one day. In fact, Jesus left and he said, I'm going to prepare a place for you. Okay? And it's for all of us who put our faith and trust in him. And if you haven't done that, you really need to. Okay? You need to put your faith and trust in Jesus. So, that's all I have on astronomy. I want to take some questions.